You know how we always talk about technical debt? It's like it's this mysterious force, some kind of rust or rot that just happens to code over time. But what if it isn't random at all? Today, we are going to pull back that curtain and look at why systems really break down. And spoiler alert, it has a lot less to do with messy code and so much more to do with power, pressure, and incentives. Let's dive in. And this is really the core idea for us to explore. Systems don't just fall apart by accident. They actually decay along very specific fault lines, and those lines are drawn by the organizations that build and maintain them. It's a pretty provocative thought, right? And it's one that completely changes how we should be tackling this problem. So here's how we're going to break this all down. First, we're going to challenge that common narrative around tech debt. Then, we'll get into the two hidden forces that really shape our systems: incentives and power. From there, we'll see how tiny little debts can snowball into a massive crisis, and we'll expand our view of debt beyond just the code. And finally, we'll figure out how to turn all this understanding from a diagnosis into an actual strategy. All right, so first things first, let's start by dismantling that old story. This idea that technical debt is just some natural, unavoidable part of software development, well, it's not just wrong, it's actually really unhelpful. It stops us from seeing the real causes and, more importantly, from finding any real solutions. I mean, the myth is convenient, isn't it? It's just so easy to point fingers and blame individuals. Oh, it's bad engineers, it's laziness, a lack of craftsmanship. But the reality is, it's a systems problem. On a systems level, technical debt is really just deferred maintenance. It's risk that we've all decided to hide for now, and it's the unpaid interest on a loan that we will have to pay back, one way or another. So let's get really clear on our definition here. This is not about sloppy work. Technical debt is the direct result of a whole series of rational, even if they're short-sighted, decisions. It's what happens when the pressure to deliver something right now completely outweighs the need to build it sustainably for the future. So the key point is, these are choices, not accidents. And that brings us to our first major force: incentives. This is like the invisible architecture that dictates almost everything. Because at the end of the day, people respond to what they are rewarded for, not to what's written in some best practices handbook. So what are those incentives in most places? Sound familiar? Ship faster, cut the budget, make those quarterly numbers look good. And maybe the most powerful ones of all, the incentives to avoid blame and just push the hard decisions off to some future team. You'll notice that build stable, long-lasting systems very rarely makes that list in practice. This is a fundamental truth of engineering, and honestly of any human endeavor. If you really want to understand why a system is the way it is, why it feels brittle, why it's so hard to change, why it keeps breaking, don't look at the code first. Look at the incentives that created it. If you remember just one thing from this section, please make it this. When you see a system that's struggling, resist that urge to blame the competence of the engineers. Instead, you have to ask, what were they incentivized to do? Because when the system rewards speed above everything else, debt isn't just possible, it is absolutely inevitable. Okay, so if incentives are one side of the coin, then power is the other. Once the debt is there, power is what determines what happens next. It's what decides what's even considered a problem, who gets to complain about it, and ultimately, whose pain matters enough to actually get fixed. Just think about it for a second, where you work. Who gets to decide which bugs are P0s and which ones are just going to languish in the backlog forever? Who decides which customer complaints get escalated versus which ones just get ignored? Whose workflow can be totally broken without any real consequences? The answer to all of those questions is simple. It's power. It's not about technical severity. It's about who has the influence to make their problem the organization's problem. And here's the uncomfortable truth that follows right behind that. Technical debt is not distributed evenly. Its costs are almost always pushed onto the people with the least amount of say. It gets exported from the company to its users, from leadership down to the engineers on call, and, maybe most commonly, from the team making the decision today to whatever poor team inherits the mess tomorrow. So you've got these forces of incentives and power creating all this debt. Now let's look at what happens when it starts to pile up. Because technical debt, just like financial debt, has this really nasty habit of compounding. Small, totally manageable issues can spiral into a full-blown crisis before you even know it. It all starts so simply, right? A decision is made to prioritize speed, but then the interest payments start coming due. The cognitive load on engineers just goes up and up. They have to remember all the weird workarounds. Then the system's flexibility just tanks. Every single new feature feels risky and might break something totally unexpected. And that leads directly to burnout, because your best people get tired of constantly fighting the system. Eventually, you hit that final stage. The system becomes so fragile and so complex that it is just too expensive and way too risky to change at all. And yet, through all of this, you will hear this phrase. It is the single most dangerous justification in all of engineering. It's what we tell ourselves as the workarounds pile up, as heroic engineers pull all-nighters just to keep the lights on. But this perception, it's a dangerous illusion. That's the illusion. What we call resilience is so often just survival that's being funded by debt. The system isn't strong. It's just being propped up by unsustainable effort and, honestly, a lot of luck. A truly resilient system doesn't need constant heroics just to function. When outages become normal and every recovery requires a bunch of manual intervention, you're not resilient. You are just one bad day away from bankruptcy. Now, it is absolutely crucial to understand that not all debt actually lives in the code base. In fact, some of the most damaging debt is organizational. The problems you see in the code are often just symptoms of much deeper issues in the culture and the structure of the team itself. Think about stuff like tribal knowledge, where all the critical information only lives in one person's head, or terrible documentation that makes bringing new people on a total nightmare. Think about undefined ownership, where everyone just assumes someone else is responsible for that critical component, or fear-based cultures where nobody feels safe enough to admit they made a mistake. These organizational debts, they create technical debt faster than any single bad coding decision ever could. And this really explains why paying down any kind of debt, technical or organizational, is just so politically difficult. I mean, the work itself slows down the creation of new, visible features. The benefits, like more stability or faster development in the future, are often completely invisible to management. It requires long-term thinking in a world that only rewards quarterly results. And maybe most importantly, the people who benefit the most are often future employees or users, people who aren't even in the room when the decisions are being made. So, after all that doom and gloom, what's the solution? We can't just wish debt away. The goal has to be to move from being a victim of debt to a responsible manager of it. And that requires a conscious strategy, not just good intentions. So, what does a wise strategy actually look like? Well, it usually involves these 5 things. First, you have to make the debt visible. Track it. Document it. Second, stop talking about it as messy code. Tie it directly to business risk. Say, this component slows down all new feature development by 30%. Third, you have to allocate a specific, non-negotiable part of your budget to paying it down. Fourth, when you do decide to take on debt on purpose, design an exit strategy for how and when you're going to pay it back. And finally, you have to revisit these decisions regularly to make sure those trade-offs still make sense. And this brings us to a much more sophisticated way of thinking about this. The goal is not zero debt. Sometimes taking on debt to hit a market window or to test a hypothesis is absolutely the right strategic move. The danger isn't the debt itself, it's the unacknowledged debt, the debt you just pretend doesn't exist, that isn't tracked, that has no repayment plan. That is what leads to bankruptcy. So let's bring this all home. The single most important shift we can make is to stop viewing technical debt as some kind of moral failing of our engineers. It's not about being good or bad. It is simply a signal coming from the system. It's a signal telling you that your incentives are totally misaligned with your long-term goals. It's a signal that there's a power imbalance, where all the costs are being shouldered by those who have no voice. It's a signal that the system is optimizing for completely the wrong time horizon. You see, true engineering wisdom isn't about writing perfect, debt-free code from day one. That's a fantasy. Real wisdom is the ability to read these signals from your system, to understand what they're telling you about your organization, and then having the courage to address those root causes, not just the symptoms.